Now we've talked about how to find the standard deviation of a population, but of course in real life it's often impractical or impossible to find all the data for a population. That's why we sample a population, right? So what we would like to do is be able to find the standard deviation for a sample. And the goal is we want the standard deviation of our sample to be a good approximation of the standard deviation of the population, the best we could do anyway, okay? So let's first review what this looks like for a population, and then we'll talk about how to find things for a sample. So for a population, and remember we have special symbols here. So for a population, the mean is mu, and we add up all our data and divide by how many values there are in the population, how much data is in the population, which we notate by capital N, okay? In the sample, it's almost the same. We just switch out the symbols we use. So in a sample, we call the sample mean x bar. That's how we say that we're dealing with the mean of a sample, okay? And we do the same thing, though. We add up all the values in our sample. We divide by how many there are. We just denote the number of data values in our sample by little n instead of big N. Okay? So straightforward. Essentially the same formula, we're just switching out some symbols. For standard deviation, it's not quite so simple. For population, our standard deviation, which we notate using the Greek letter sigma, we add up all our deviations, x minus mu squared, divide by how many there are. Okay, that way we're averaging the squared distance of each data value from mu. And then to correct for the square, we take the square root. Okay? The sample standard deviation is almost the same, but it's not quite as simple as just just changing out some symbols. Okay? So the sample standard deviation we notate with a lowercase s, and it starts off about the same. We look at how far each data value in our sample is away from the sample mean. Okay, we square it to get rid of the direction information. We just care about the distance. And then instead of averaging it, we still add them all up. But instead of dividing by n, we end up dividing by n minus 1. One less than the sample size. Okay? And so that's a pretty significant difference between the two formulas. That goes beyond just switching out the symbols. And so it's going to be really important that you know when you're dealing with a sample and when you're dealing with a population. Okay? Because the formulas are different. So why is it different? Why do we have n minus 1 here instead of just n? Well, remember what the goal is. We want our sample standard deviation to be a good approximation for our population standard deviation. Our population standard deviation is a measure of the average distance of the data from the population mean, mu. What are we calculating over here? We're calculating the distance of each data value in the sample from the sample mean, x bar. Now, x bar should approximate mu, but they're not the same thing. So S isn't, or if we just had n here, it wouldn't quite be the average data. We wouldn't be approximating the average distance from mu. We would be measuring the average distance from x bar, and that's not what we want. So to correct for that, we throw in a minus 1 down here. And it's a little bit complicated why that works. If you're interested, you could take a more advanced statistics course later on. But it turns out that's the magic formula that will correct for that small error. Okay? So that is our formula for our sample standard deviation. In the next example, we'll show how to calculate the standard deviation for a sample.